here to talk to you about the rise of the machine, or basically how AI crawlers are ruining the lives of everybody that is a system meaning for a MediaWiki installation. And specifically, I'm going to talk to you about what's happening to one of the biggest MediaWiki installations in the world, which is the one that the Wikimedia Foundation runs. And I'm going to go through what is the impact that we're observing, like what are these bots, why are these bots a problem for us, and what we built to respond to that. And finally, I'll show you some magic 7 lines of code that will solve most of your crawler problems. I promise. So let's start with the impact. In the graph that I'm showing here, which is the graph for our egress bandwidth, so the amount of bandwidth that we send out, you can see here some spikes, right, for some notable events from the last 4 years, but you see that the baseline is basically flat, right? Until 2024, when something changes, and we saw a 50% plus increase that is still ongoing. The image that I have here is just updated to January, but it's still ongoing. On the amount of egress bandwidth that we're doing, we asked ourselves what's going on there, and we found out that basically largely caused by bots, by AI crawlers that are crawling our commons repository of free images. This is, of course, not sustainable long term because we don't want to spend more on bandwidth, which is pretty expensive for this reason. Also, this increasing baseline makes it harder for us to serve tragic, like dramatic events where news break, like you see here the spikes for US election day and Jimmy Carter's death. But in general, we're very good at serving these spikes because our infrastructure is optimized to serve humans. What I mean is that, if we had to serve the amount of requests that we have normally via just MediaWiki, we would need a huge infrastructure. Instead, it's pretty small. We have 2 main data centers and 5 caching centers that are just caches in front of our wikis. And your requests get routed to the one nearest to you, where pages are cached in memory. So if somebody is seeing the article that you're looking at 5 minutes before or during the same day, it's probably going to be served you very fast from the RAM of the server in the local data center. This allows us to serve a lot of requests because mostly what we found out is that humans are not that original. So the traffic that we generate tends to cluster on the same number of pages. So the cache hit ratio that we get is pretty good. And so most of the requests are served from this cache. Now, what I'm showing here is one example of how we can withstand very well this amount, the very large amount of traffic coming from humans, which is the recent day of the election of a pope. We just passed our daily peak, which is around 180,000 requests per second, and then the white smoke went out. There was a huge increase, and then they announced the name of the pope, and we spiked at 725,000 requests per second. Now, in contrast, this is the front end. On the back end, we saw an increase of 5,000 requests per second at peak, because that's served by MediaWiki, which is much more expensive, right? So our infrastructure can withstand a lot of traffic from humans because humans tend to cluster their interest. Bots, on the other hand, they don't. And they tend to browse websites across all the URLs that you have, so these caching strategies that we have don't work very well. To the point that while 35% of all requests that we get are coming from bots, about 65% of the requests that get to the backend, so to MediaWiki, are clearly from bots, that don't even try to look like a human, like a browser. But this is not the only reason why this bot is very expensive for us. The reason why it's expensive, it's also the human capital, which is the one thing on which I think we have in common with everybody else who's dealing with the AI crawlers, which is the constant disruption of the workload of teams. Like suddenly there's an incident every few hours, which is maybe a minor disruption, but still it needs somebody to stop their work, go to look at the traffic, find out which crawler is causing problems now, and close clipping that is like a lot like a never-ending game of whack-a-mole, right? If you do it this way. And sadly, there's no limit to the appetite of these crawlers. They crawl literally everything that we expose over HTTP anywhere, from the code review platforms that are hit a lot, like a lot of infrastructure of free knowledge is, and free software specifically, is hit in the same way, but also everything else, like including things that are downright weird. Like we have had a couple of incidents where an aggressive crawler would make our Docker registry unavailable, which is like, I don't know, and even our test clusters are dealing daily with bots, like clusters where we really literally have only test content. And also, I think you probably might have noticed, some of you might have noticed, but something that we've noticed a lot is that not all the traffic that presents like one of the big players, so I don't know, like ChatGPT bot or Google bot or whatever else, is actually coming from, is actually what we're pretending to be. There's a lot of impersonation. To the point that there's a myriad of small and large cloud providers from which this traffic is coming, but it's not coming from, say, OpenAI or Anthropic, just to name a couple, but you can think of all of these big players. So this is a problem that is real. Like, you might perceive like, I don't know, CloudBot is making a lot of traffic on your website, while in reality, what's happening is somebody else is mimicking their user agent because they expect that to be something desirable. Now, this is the landscape in which we're moving. How we at the foundation struck back? Well, we created our own web application firewall, which is called requestCTL, that integrates well with our caching layer and allows us to basically filter out or rate limit or bandwidth limit most of the traffic that we get. We do some categorization of traffic, so we want to know if traffic is coming from the public cloud or if it's coming from a residential ISP. We want to know if it's coming from a bot that we trust, from an IP space that we trust. We do some very rudimentary crawler fingerprinting, and we apply limits based on that. I don't want to spend a lot of time on this because I want to leave some time for questions, but this is what the whole thing looks like. You can see it basically in green in this complex scheme, this arrowhead that I'm showing, are the points in which we make detection, and then in red are the points in which we take actions to detect traffic. But basically, traffic that's incoming goes through a lot of these kind of filtering at various levels, and yeah, let me go through the things that we actually do in practice. We verify the origin of the request for non-crawlers, for the large crawlers, from which we keep a database. And we do some basic crawler detection, as I said, basic because while it's pretty hard to properly simulate the browser, a lot of these crawlers don't even try. The list of things that you could check for are, is this client setting cookies? Do they execute JavaScript? Is the header order what I would expect from this browser? Is the TLS cipher used by this client the same that I would expect from this US browser combination? Yeah, okay, all these complex things, you don't really need them. And I'm getting to the sales pitch of the talk, which was the 7 magic lines of code that you can use. And it's basically a few lines in your Apache configuration. I'm sure you can't see them properly on the screen right now, but let me describe you what they are. Basically just banning in your Apache configuration, Apache HTTP configuration, all browsers and all operating systems are supported by the user agents. Reduce that we just, this is literally the lines of code that we have added to our Gerrit repository configuration. So the thing from which you typically clone MediaWiki when you're coding on it or you're using it. It reduced, just adding these lines, reduced the amount of crawling that we're getting on our code repositories by 70%. I would add, without disruption to our real users or showing them anime at at some point, like some other solutions do. So my suggestion for people that have a small website, where small means you're not dealing with tens of thousands of requests per second, and so even these small crawlers, these localized crawlers are a problem here. I would say the first thing you should do is probably ban all .browsers and OSs unless you're running a Microsoft Windows or computing community. I would also use robots.txt crawl delay to suggest that people just browse your site slowly and ban anything that doesn't respect it. And you can do that with moderate limit in Apache, for example. And as a last resort, just verify that clients can process JavaScript. But please don't learn more of a planet with useless proof of work schemes. Okay, this is all I had as a presentation. I think I can stop presenting and take questions.
Yes, hello. Oh, hello. Okay, great. Thank you, Giuseppe, and no offense to all the other speakers at this conference, but I think this is the talk that has the most public appeal, will have the most public appeal from anything here, because there's literally millions of people who are having this problem, I think, and I think a lot of people are curious how the big websites are handling it. So yeah, we have questions. Go ahead. Oh, yeah.
So on the last slide there, you said, block bots that don't respect the crawl delay. What is your technical, how do you actually implement that? What are the tools you use?
So I'll say we are not doing that right now, but my suggestion is to probably use something like moderate limit and use it for anything that doesn't present the typical, like, under the case in Apache HTTP, for anything that doesn't present as a real user browser. So something that doesn't have Chrome or Gecko in their string, like you can look that up, and that's basically the way that I would do it. Like anything that doesn't present as a normal browser, just limit it to one request every n seconds, for example, with moderate limit. And then for real browsers, kill anything that's older than n years. It's your choice how inclusive you want to be.
Okay. Sorry.
Question from YouTube.
Oh, there's a question from YouTube. Okay. Gosh. While I get that, I was wondering, is the anti-proof of work thing, is that your personal opinion, or is that the opinion of the Wikimedia Foundation in general?
Oh, sorry, yes, I should clarify. Everything that I stated today is my personal opinion, clearly. It is my opinion. I also don't think that it would be practical to do any proof of work scheme for the wikis. So I am, anyways, one of the persons in charge of doing the technical implementation of responding to AI crawlers. So if the question is if that's an official position from the Wikimedia Foundation, it's not. If the question is, are you going to see proof of work on Wikipedia soon? Probably not.
All right. We have another question. How's the live stream? It's fine.
It was good for 11 minutes.
Yeah.
And now it's back to being flaky.
Okay, the live stream was a little flaky, but hopefully we're capturing all of this. We have another question from online. Do you actually want LLMs to have access to Wikipedia data directly, or are you pushing them towards Wikimedia Enterprise?
So I am completely agnostic of which way, and again, it's a personal answer, but I can also give an answer from the Wikimedia Foundation, which is, as stated in our robo policy, is that we would like them to use dumps. Be that the dumps that we offer directly ourselves, or the HTML dumps that they can get for free on Enterprise, by the way, from what I remember, but don't quote me on that. I've never looked at what they offer very thoroughly. So, yeah, the point is, offline consumption is more sustainable for us. And in any case, for example, for media, it's just simply that we can't sustain many actors downloading our stuff. We will have to find a solution. We don't have a solution for dropping offline images, right? The binaries actually at the moment. Just offering a dump is not really a long-term solution for that in terms of our abilities to offer that.
All right, that seems like a good place to wrap it up. Thank you very much, Giuseppe, for coming on and sharing your expertise.